An elementary introduction to the Wolfram language. Lesson 10. Images.
In this lesson, we will be learning about images in Mathematica. The first step is always to get the actual image into Mathematica. That can be done by copying and pasting it in, dragging it in, or using the function import on the directory of your image. Here, though, we will get an image in a simpler way, with the function randomImage. So here I'll type random image of nothing, hit Shift Enter, and as you can see, I get an image of random pixels. Another fun way to generate images is with the freeform input. To do this, press Ctrl and equals. You then just type what you want and you get it. So here I'll type Ctrl equals of picture of a dog, hit Enter, and we get a picture of a dog. Here we'll do Ctrl and equals of picture of Jonah Hill, and we get a picture of Jonah Hill. Here we'll do Ctrl and equals of picture of a watermelon, and what do you know, we get a picture of a watermelon. Now let's learn how to process these images. First, remember that Mathematica is symbolic, meaning that you could interact with images in the same way you would interact with anything else in Mathematica. You can copy images, you can paste images, and you can write code around images. So here we will take a tiger and use color negate on it. So here we'll do Ctrl equals of picture of a tiger, hit Enter, and what do you know, we get a tiger. Now we'll do color negate of the tiger, hit Shift Enter, and we get an image of a tiger with the colors negated. Here, we will make the picture of the tiger lighter. So we'll do lighter of the tiger, hit Shift Enter, and we get a lighter tiger. Then, to make it even lighter, we'll just wrap it in lighter again, hit Shift Enter, and we get a lighter tiger. Here, we will blur the image. So we'll do blur of the tiger, hit Shift Enter, and we get a blurry tiger. Now let's add in a manipulate and change just how much it's blurred. So we'll do blur of the tiger, n, then we'll wrap it in manipulate, comma the list of n, 0, 20, hit Shift Enter, and we get a manipulate. As we move the slider, the blurriness of the tiger changes. And now let's make a table of the blurred tiger where it gets progressively blurrier. So we'll do blur of the tiger, n, then we'll wrap it in table, comma the list of n, 0, 5, hit Shift Enter, and we get 6 tigers, each a little bit blurrier than the last. And here let's make an image collage of it. So we'll take the same code from before and wrap it in image collage. We then hit Shift Enter, and we get the same tigers as before, but rather than being in list format, they are now a collage. Now let's talk a bit about the image analysis tools. The function dominant colors finds the most important colors in the image. Now, I don't know about you, but I'm getting kind of bored of using the tiger, so let's switch to a different animal. For example, sheep. So we'll do Ctrl equals of picture of sheep, hit Enter, and we get a picture of sheep. Now, I don't like those sheep very much, so let's take a ram off the internet instead. Note that here we will use a variable called ram. We will set it equal to the image, so we don't have to copy and paste it into our code every time. Instead, we can just refer to the variable. So here we'll do ram equals import of this URL, hit Shift Enter, and what do you know, we get a ram. Now, let me refresh your memory about what we are going to do to this ram. We are going to use the function dominant colors to find out what colors are the most dominant in the image. So here we'll do dominant colors of ram, hit Shift Enter, and we get the dominant colors. Another analysis function is edge detect. It detects the edges of an image. Here let's use it on our ram. So we'll do edge detect of ram, hit Shift Enter, and we get a ram with all its edges detected. Another cool image capability of Mathematica is that it can use image functions on graphics objects, and the graphics object will be converted to an image. So we'll do graphics of a circle, hit Shift Enter, and we get a circle. Then we'll wrap it in edge detect, hit Shift Enter, and it becomes an image with the edges of the circle detected. Here, we will import a wolf from the internet and use image effect to make it look awesome. Note that we are again using a variable. This time, it will be wolf. So we'll do wolf equals import of this URL, hit Shift Enter, and we get an awesome wolf. Now we'll do image effect of wolf, charcoal, hit Shift Enter, and we get a wolf that looks like it was drawn in charcoal. Here, we will do something even cooler. We will create a wolfram by merging the wolf and the ram using the function blend. So we'll do blend of the list of wolf, ram, hit shift enter, and we get a blended wolf and ram. This is wolfram. The last function I want to talk about is one of my personal favorites. It is binarize. It puts the image into black and white, into binary ones and zeros. Here I will binarize the wolfram. So here I'll do binarize of wolfram, hit shift enter, and I get a black and white binarized wolfram. Here I'm going to do something incredible. I'm going to binarize myself. First, I'll use current image to take a selfie. So I'll do current image of nothing, hit shift enter, and it's me. And now I'll binarize myself. So I'll do binarize of me, hit shift enter, and I get a black and white binarized me. Thank you for watching, and I will see you in the next lesson.